In this video we are going to discuss about DHCP failover on Windows Server 2016. DHCP failover first came out on Windows Server 2012, and with failover you can ensure that you have continuous availability for your DHCP service. The basic way in which a failover works is that you have two DHCP servers for which you configure one or more failover relationships, and through those relationships then the DHCP servers can share leases and also other settings. In case one of the servers fails, then the other one will continue to service DHCP. Before we go on to talk more in depth about failover, let's discuss the previous ways that you could obtain continuous availability for your service. The first would be to create a failover cluster in which you will include the DHCP service. But of course this means that you have to have a shared storage, and there's also the networking complexity. It's not very feasible. The second way in which you could obtain continuous availability was with split scope DHCP. This would mean that for a given address range, you would cut it in half basically, and each one of those two ranges would be placed on one of your DHCP servers. So then you would have two scopes that would continue from one to the other, but they are not really in sync. None of them knows what the other is doing. So enter DHCP failover. It uses relationships. So the relationships are the basic unit of DHCP failover, and through these relationships it replicates one or more scopes between two servers. A DHCP server can have failover relationships with one or more servers, but very importantly is that each scope can be part of only one relationship. Also, one DHCP server can have a maximum of 41 relationships, which I think is more than enough. Failover has two modes of operation. The first one is hot standby mode, and in this mode we have one server that will respond to DHCP requests and another one that will wait in standby mode. If the active server for some reason does not respond anymore, or the DHCP service is not available, then the standby will take its place and start servicing DHCP clients. We also have load balance mode, in which both servers are active at the same time and respond to clients. This means that a percentage of IPs is given to each server, usually it's 50-50 by default, and only in case one of the servers goes down, then the other server will get 100% of the IP range. So now that we saw how failover works, let's discuss the two time intervals that are very important for the understanding of DHCP failover. First is the state switchover interval, and this period of time is the time that a server waits in the communication interrupted state before it transitions to the partner down state. This of course in case that automatic state transition is enabled. We also have maximum client lead time, or MCLT. This is the amount of time that a lease is available for when it is granted by a DHCP server when its partner is down and it is in a transitional state. It also is the amount of time that a server waits in the partner down state before it will take full control of the scope. So first let's talk about load balance mode. We start with one DHCP server that has a scope on it with a range of IPs, and a DHCP02 server that only has DHCP installed as a service. If we want to use DHCP failover, the first thing we need to do is configure a relationship between them and tell the relationship that the DHCP scope is part of it. So now we have a relationship created between these two servers, and the first thing it will do, of course, is copy the scope to DHCP02. So we will have our DHCP scope here, and it will also get some IPs. But now this is the interesting part regarding the IPs. When you create this relationship, since it's in load balance mode, you will specify a percentage. And let's consider that in our case the percentage is 50-50. So everything that is here in the red part cannot be used by DHCP01. And of course, everything that is in that red part will be able to be used by DHCP02, but not the other one. So this one cannot use this part. This is how load balance mode works. Now each server can hand out IP addresses and at the same time communicate with each other to let the partner know, hey, I handed out this address and this address, even though it's not part of your assigned percentage. But if something happens and, for example, DHCP01 fails for some reason, it's not available anymore, then the DHCP02, after it waits, we will see in the slides, after it waits some time that we can configure, it will have to assume the role of the sole DHCP server and take over also this part of the IP addresses. So at this point, our DHCP02 will hand out addresses for the entire scope. Of course, as soon as DHCP01 will recover, after a short time in which they communicate and O2 lets it know what has happened since it was gone, the normal operation will be reverted. DHCP01 will assume its percentage of addresses, O2 will assume its percentage, and they will service clients as normal. Now let's also talk about the hot standby mode. Again, we start with two servers. One of them is configured with a scope. One of them just has DHCP installed on it. And if we want to enable failover, of course, we create a relationship between them. This is the relationship. And like in load balance mode, the relationship will first copy the scope also on DHCP02. Okay, so we have our DHCP scope. But this time it's a little different. In hot standby mode, the only server that will service clients in a normal operating environment will be the active one, which is O1, and DHCP02 will be standby. But on O1 we also have to configure a very small percentage of IP addresses, let's say 5%, that in case it fails, until DHCP02 will assume full control of the scope, it can still service new DHCP clients. This is the role of this small percentage of IPs that we reserve. And in case O1 now fails, what will happen first on O2 is it will sense that O1 has gone away, and it will enter a state called communication interrupted, so CI. While it is in this state, it will use this small percentage to service clients, and also a timer will start, at the end of which the status will switch to partner down state. So after that timer has gone down, this server enters partner down state, and another timer will start counting, and at the end of that timer, then DHCP02 can finally assume full responsibility of the scope. Until then, it is still using that small percentage in red. So now, after the timer is gone, on DHCP01, we will not have any more IPs that are given out since it's gone, and DHCP02 will take care of everything from now on until DHCP01 comes back from the dead. Even though DHCP02 will service the clients with all the IPs, it will still be in standby mode. It still shows up as the standby server, since DHCP01 is configured as the active server in this relationship. So once it comes back alive, it will reassume its role as active server.